Hello everyone and welcome to the Maths Mock Paper 3 questions 2 to 21. Now this paper 3 actually, I've only just finished marking it. I realise it's just as hard really I think as the first paper. It's got some tricky bits. Anyway, let's get on with it. Mrs. Atkins is going to choose 2 students from her class to take part in a competition. She's going to choose 16 girls and 14 boys, yeah? So work out a number of ways you can choose this. Well, the 16 girls are all in their own group. Now imagine this, I call this a possibility tree. You've got 16 choices for the girls. So you're going to have 16. But then for each girl, you could choose 14 different boys. Yeah? And so you're going to need to do 16 times 14 for this one. And that's going to be 160 plus 64, so 224 possibilities. Yeah? Now contrast this question with the next one, which isn't as simple because the next one says work out a number of different ways of choosing 2 boys, yeah? So we're choosing from the boy pool twice, yeah? So you've got 14 choices on the first one, and on each one of these branches, you've got 13 possibilities coming up. So most people were doing 14 times 13. But, you might think that's the end of the story. Now 14 times 13, what is that? 130 plus 52, so 182, yeah? Now, that is not the answer, and that's because we would have double counted some of these, because we would have counted, like, let's say the first boy's name is Alex and the second boy's name is Ben, yeah? Well, we would have counted the choice Alex and Ben, but also the choice Ben, Alex. Note this is not a problem we would have had above here because the girls and boys are in distinct subsets, yeah? We're choosing from the same pool this time, and because we're not interested in the order, we need to divide by 2 here. So we need to do 182 divided by 2, and so the final answer is 91. That is subtle, yeah? Watch out for double counting in these questions. I mean, to be honest with you, if you do that, you're getting 1 out of 2 marks. So to get 1 out of 2 marks, you need to basically subtract 1. You can't do 14 times 14, you must do 14 times 13. And then it's obvious that you've considered the fact that they haven't been replaced. But yeah, there's a subtlety there. You have to divide by 1 at the end. Think of it like this. Think of it with much smaller numbers. If you had John, Dave, Bob, and Graham, yeah? If we were choosing 2 from those 4 there, then you might think we've got 4 times 3, 12 possibilities. But actually we've only got 6. JD, JB, JG, and then you've got DB and DG, and then you've got BG, yeah? There's only 6 ways of choosing a pair, unless you care about the order. If we were to change this question and say, work out a number of different ways of choosing a head boy and a deputy head boy, suddenly the answer is 182, because it's a different arrangement if you've got John as head and Dave as deputy head, and then if you've got it the other way round. Okay, so question 13. Subtle that one, though. I can understand people making a mistake there. All you've got to do here is plug in the number 1 into this. So I'm going to call this, I'm going to say let f of x equal x to the 4 minus 3x minus 1. Just so I can show the examiner I'm clearly plugging in 1. And I'm going to work out what that is. 1 minus 3 minus 1, that's minus 3. Now I'm going to plug in 2. You've only got to plug in 1 and 2 here. And that gives me 2 to the 4 minus 3 times 2 minus 1. That's 16 minus 6 minus 1, so that's 9. Now all you need to remark is change of sign. Hence, 1 is less than x is less than 2 for the solution, for our solution. Now, if you're wondering why that works, think of the graph, yeah? We've shown that we've got this curve, x to the 4 minus 3x minus 1. And we've shown that when x is 1, you get minus 3. And when x is 2, you get 9. So the answer for where it's 0, where f of x equals 0, must be somewhere between 1 and 2. Because, if you like, in old money, 2 is too big because it ends up being 9, and 1 is too small because it ends up being minus 3. So it must be somewhere in between that. So that's all we need to remark for that. This is called fixed point iteration, this method actually, and it's new to Gcse, but it's also in A level. What are we going to do here? We're going to add the 3x and the 1 over first. They had to see this according to the mark scheme. They had to see that line, and then you can just write down fourth root of 3x plus 1. and you've got the answer. Okay, use the iteration formula once, just once, yeah? So this formula is telling us the next term is the fourth root of the last term plus 1. Sorry, it hasn't rendered very nicely on my screen there. That should be a little n. And so if you want to work out x1, you just need to do fourth root of 3 times x0 plus 1. But x0 is 1, and so that's the fourth root of 3 plus 1, 4. And if you do the fourth root of 4 on your calculator, it's actually root 2, which is 1.414. Next question. What are we doing here? Finally, show that the perimeter of the shaded region is given by that. Once again, a 5 should be in the middle. Looks a bit weird there. Okay, so how do we find the arc length ABC? Let's find that first. Well, we're going to have to do 108 over 360 multiplied by, now you need the circumference of a circle. This just finds you the fraction of the circle you're dealing with, multiplied by the circumference, which is 2 pi r. But r here is actually r plus t. So we're going to have r plus t. Now, simplify that on your calculator, and I think you'll find, what is it, 6/10? Let's have a look. 108 divided by 360. That's 0.3 times by 0.2. Yeah, basically this comes to pi r plus t, 6 pi r plus t over 10. Yeah? And in fact it will say 3 pi r plus t over 5 on your one. In fact, let's write it like that. 3 pi r plus t over 5. And your calculator will simplify that for you. Yeah? If you do a 108 over 360 times 2, you'll get 3/5. Okay, arc length FED. So I've worked out that one. Now I'm going to work out this one, because then I can just add a t and a t. Arc FED is 108 over 360 again, times by 2 pi r this time, just 2 pi r on its own. So that's going to be 3 pi r over 5. And now we've just got two t's here and here. And so the perimeter is going to be equal to 2t plus 3 pi r plus t over 5 plus 3 pi r over 5. Now I'm just going to combine that, and I'm going to get, now we need a common denominator here, so write 2t as 10t over 5 plus, I'll multiply out these brackets, 3 pi r plus 3 pi t over 5 plus 3 pi r over 5. We've basically got the answer now, because look at what we're heading to. We're heading to this, 6 pi r, well that's 3 pi r plus 3 pi r. And then we've got 3 pi t, well that's there. And then we've got, let me just move the screen so we can all see it clearly. And then we've got the 10t on the end. All over 5. Done. Yeah. Make sure though, on those show that questions, make sure your working is really easy to understand, because you're far less likely to get it. Do not expect the examiner to care about your grade. They don't, yeah? They're people who are marking in July, and they're doing it to get money, so they've got money to spend on holiday, yeah? The last thing on their mind is, oh, what about this kid? Maybe they don't get a 7. They don't care. They really don't care. They're going on holiday. You're just another script to them. So make it easy for them to give you the marks, yeah? Okay, next one. Find the exact value of this when r is 0 and t is 10. Okay, exact. That means leave your pi's in. If you've got an answer of 38, you didn't leave the pi's in. Simplest form, cancel it down. So we're going to plug in r is 0, so that first term disappears. We're going to plug in t is 10, so that becomes 30 pi this term. And then this becomes plus 100, and it's all over 5. But simplest form, 30 divided by 5 is 6. 100 divided by 5 is 20, so that's 6 pi plus 20. Now, what does this represent? Well, I wanted you to be precise here. You had to say it represents the sector perimeter OCBA, because R has gone to 0. So this has all become shaded. Yeah, T is 10, R is 0. So that just kind of moves that over there, and suddenly you're working out the perimeter of sector OABC. So we just have to say here, the perimeter of the sector OABC. Then you get full marks. Okay, I agree though, those wordy questions, students are never very good at realising what the examiner's actually asking for there. It's sometimes a bit hard as well. You feel like you've got to guess what's in the examiner's head. Okay, C is inversely proportional to D. That means C, funny fish sign, 1 over D. You can swap the proportional sign for an equals, provided you times by a constant of proportionality. You can put that there, or you can put it on top. It's completely up to you. Now we're just going to plug our values in to find that constant of proportionality, k. So if we use c equals kd, k over d, just draw that nice and neat. We're just going to plug in 0.5 equals k over 6. We're going to times 6 over there. 6 times a half is 3. So k is 3. So c equals 3 over d. Now just quickly have a look. Does this agree? Yeah, because when d is 6, c ends up being a half. Looks good. Next one. Okay, this one's hard. There's no doubt about it. And if you did it with trying to show, like basically saying, oh, green is 1, therefore blue is 6 and stuff like that, I think I gave you 3 out of 4 marks for that. You might be lucky and get 4 in the exam, but what they really wanted you to do was prove it for any value, provided these statements hold, because it works provided any statement holds. So we're going to show that to the nearest percentage of blue counters in the box is 57%. So what are we told here? Well, firstly, we've got the total. The total is B plus G plus R plus Y. And this is where R equals number of red counters, G equals number of green, etc. Yeah? Tell the examiner what you're doing. Yeah? T is going to be the total. Yeah? Now, why would I be interested in the total? Because I've got to work out the percentage of blue counters in the box, in other words, out of the total. So I do need to know the total here. Now, really, I need to boil this all down to one variable. Yeah? So what's the total? Well, B plus G, we've got over here, if I just write this down here, and if you wrote this down somewhere, you would have got some credit. Blue and green is double the number of red and yellow. So if you like, B plus G is double red plus yellow. So what I can do here is I can get rid of the red plus yellow and write it all in terms of B plus G, because red plus yellow is a half B plus a half G. Yeah? So now at least I've only got blues and greens. Really, I just want blues because I want everything in terms of blue, because then I can just do number of blue counters, which is B, divided by the total number of counters, which will solely be in terms of B. So the B's will cancel and I'll get the percentage. Okay, what's the other thing I'm told? Number of green counters is 1/6 the number of blue. Now, using this, I can say the green, well, if that's 1/6 the number of blue, then times the greens by 6 and you get the blues. Yeah? In other words, G is B over 6. Yeah? Now I can write down the G's as B plus B over 6 plus a half B plus a half times B over 6. Well, let's now do a little bit of fractions. Let's put them all over 6. So B is just 6B over 6. Then I've got a B over 6. Then I've got a half B, so that's 3B over 6. Yeah? You see what I'm doing? Common denominator. Now here you're going to have B over 12. So actually I should have put them all over 12. I didn't see that. Okay, so let's do it again. Obviously this is going to be 12B over 12. Just common denominators, that's all. 2B over 12. 6B over 12. And B over 12. Now we can just add the numerators. So our total equals, this isn't the necessarily easiest way of doing it either, I'm not claiming it is, 21B over 12, but that can be cancelled by dividing by 3 top and bottom to 7B over 4. So what have we found out? We found out the number of blues is B, and the total number is 7B over 4. Well, if I want to find a percentage in the box, here's one way of looking at it. You've got the number of counters which are blue divided by the total number of counters. Yeah? But according to the way we divide back in primary school, you get 4 over 7b here. We just turn the second fraction upside down, and so that's going to be, cross out the b's because they cancel, 4/7. And 4/7 is 0.57 something or other. Let's have a look. 4 divided by 7, 571428. 5, and then it just keeps on going like that. It actually repeats between 5 and 8. Okay, so 57%. Done. Yeah, you might prefer to do a ratio approach there. There's loads of different ways of doing that. That's just the way which occurred to me when I did the question. Yeah, here's another one where there's tons of different ways of doing it, but this was probably, once again, this is a hard question. There's a lot going on there. The way to do it, I want to show you a way to do it without using sine or cosine rule. or half AB sine C for that matter. Just because some of the people watching this may be in one of the sets where they haven't done sine or cosine rule before. So here's one way of looking at it where you don't need sine or cosine rule. I do think though if you knew sine or cosine rule, that was an advantage in this question, without a doubt. Okay, what do we know about this little triangle on the end? Well, we know that that's 60, yeah, and that's 12, which means using SOHCAHTOA, I can say, let's call this x, I can say sine 60 is going to be opposite divided by hypotenuse, and therefore I can work out x, which is 12 sine 60. I'm just working it out on my calculator. I've got it in the wrong mode. Do I remember how to work this one? It's my old one. Okay, I get 10.39. I can also find this little bit down here, because cos 60, well, let's call this y, is going to be y over 12. And if you work out cos 60 and times it by 12, you get y, because that's a half times 12 is 6. And so this little bit is 6, and this bit is 10.39. I think we're in with a good chance now of getting this question right, because look at the big triangle now here. And I mean this side, 26, this side, 10.39, and this side, let's call this P, yeah, or whatever letter you like really. We can find P, can't we, using Pythagoras. So I can say 26 squared equals 10.39 squared plus P squared. And rearranging that, you get P equals the square root of 26 squared minus 10.39 squared. And that comes to, just do it on my calculator, square root of 26 squared minus 10.39 squared, 23.8. Now, why is that useful? Well, the way to work out the area of a parallelogram, and probably I should have said this at the start, one easy way of doing it is base times height, yeah? And I mean base times perpendicular height. Now, what's the base? Well, we've just worked out from here to here, it's 23.8. So from there to there, take off the 6, it's going to be 17.8. And then the perpendicular height is 10.39. And so we get an answer of, to 3 sig fig, let's just do it, 185 to 3 sig fig. It's actually 185.292, but they wanted 3 significant figures. If you use sine rule or cosine rule or half AB sine C, good for you. But you're lucky really. If you've been forced to do that without using those methods, I think you would have had a much tougher time. Okay, Frank invested an amount of money for 12 years. The graph shows Frank's value of investment over the 12-year period. Right, when a question says write down in maths, it means in some way it should be obvious. Now, don't get me wrong, I've done maths papers before where it says that kind of thing, and I'm like, they're implying it's obvious, and I'm not finding it obvious. We all feel like that sometimes. But, you know, the amount of money that Frank invested at the start, this is his value of investment after 12 years. Well, the original amount he invested is when n equals 0, i.e. £1,500. Yeah, you've just got to read off the graph there. I saw all sorts of crazy answers for that. I really didn't. I was like, it's just 1,500, like, because it shows the value of Frank's investment over a 12-year period. He invested an amount of money for 12 years. He's done all right, hasn't he, Frank? Look at that. Wow. It's like times 5. It's not bad. Okay, Frank said that 12 years after he'd made his investment, it was worth 5 times more than its original value. Now, you need to have part A right for this, really, because the original value was 1,500. The final value was 7,200, is that? 7,300? I think 7,200. So we've gone from 1,500 to 7,200. Divide that on your calculator, and I think it's about 4.8, is it? 4.8, exactly. So, not quite, yeah? Not quite. Because he said it was worth more than 5 times. It's slightly less. It's close. There we go. And that should get us the mark. Find an estimate for the gradient when n is 7. Now, there was tolerance for this answer. When you're doing a gradient on a curve, you have to do some kind of a tangent there, yeah? Now, what is it? N is 7. I'll tell you, the other way they do it, sometimes they say find the average rate of change between two values, and then you have to find a chord. But they're saying find a gradient at n is 7, so we need to draw a tangent line. Okay, right, is this going to work on this? Probably not. Which never works a straight line drawing this. I'm going to have to do this by hand. This is going to be bad. Okay, so here's where I'm drawing the gradient. Right there. So I need a straight line. Yeah, I know what you're thinking. That's not straight at all. Yeah, you use a ruler. Be better than me. And I personally find it's best to go from one square to another. I'm going up a bit there. And then do the standard approach you use for finding the gradient. Now, I'll tell you, before I do this, your answer's supposed to be between 450 and 500. That's the tolerance here, yeah? So let's see if I'm within tolerance on this. Okay, so 4 up to 10, that's a gap of 6. Whereas this is 5,000 down to 2,400. So that's a gap of 2,600. And 2,600 divided by 6. So let's do this down here. 2,600 divided by 6 equals, let's have a look, 433. There we go. So I'm outside of tolerance. Yeah, this would give me, well, how many marks was this worth? 3 marks. You get 2 out of 3 there, provided you've put your triangle on there, yeah, and you've shown you're working, yeah. Now let's leave this here, you know, so I've got it right, I don't care. The important thing is, if you draw a ruler really carefully, and then you do it, hopefully you will be within tolerance. I'm outside of tolerance. That's okay. I'm all right with that. It's the way it goes sometimes. Can't get every mark, can you, on a paper? But that's what you should have done. And if you do it carefully with a ruler, I promise you it should be between 450 and 500. Now, what does the gradient represent? It's the rate at which his investment is growing. Yeah, gradients are rates of change, and this is the rate at which the investment is growing in the 7th year. Yeah, well, at the start of the 7th year, really, technically. But there we go. Okay, right, what was the next one? Oh, yeah, this one was weird. It didn't really allow me to print it. But anyway, okay, this was done pretty good, actually, by my class. I was pleased about this. Remember with histograms, if you remember nothing else, at least remember frequency density goes there, not frequency. And frequency density you can find by doing frequency divided by class width. Yeah, that's a really handy formula. Now, this is not a particularly easy question, so I was pleasantly surprised to see plenty of my class getting it right. It was really, really good. Well done, everyone. So 6 of the babies have a weight between 1 and 2.5. Yeah. So this area represents 6. Yeah. But also that gap is 1.5. Yeah. And this is 4 high, isn't it? So that makes a lot of sense. 1.5 times 4 equals 6. Oh, I've gone too far there, haven't I? Look at that. Sorry about that. That's 1.5 times 4, which equals 6. So now we know how we can find out the other frequencies. We've just got to do, this is 0.5, isn't it? Because we're going from 2.5 up to 3, times by 40, well, that's 20. The way you work out frequency is by doing frequency density times class width. Yeah, if you times that over there, frequency is frequency density times class width. In other words, the dimensions, the area of the rectangle represents frequency. So this is another 0.5, but it goes up to 60, so it's going to be 0.5 times 60, which is 30. And this is a 1, and we're timesing it by, now careful here, these are every 2 squares, aren't they? Yeah, 2, 4, 6, 8, 10, 12. So that would be 1 times 12, which is 12. So altogether, you've got 50, 62, 68 represented, but weren't there 100? 100 babies, so we've got another 32 babies to account for. Now remember, this is frequency density. Now as that's a half across, if we put this going up to 64, a half times 64 would be 32. And so you need a bar in there. But yeah, seriously, I know my class perceive that I'm always moaning at them, complaining and, you know, insulting them and that kind of thing. But honestly, I was genuinely really impressed with how many of you got that right, because I don't think I've ever explained histograms correctly. So well, maybe this is the first year. Maybe not. 2 bags A and B each contain only green and red marbles. This was a good question, and once again, very happy at how many answered this correctly, but plenty didn't as well. And if you didn't do it correctly, it's because you didn't draw a tree diagram. This is a classic tree diagram situation, yeah? And maybe you did, but you didn't see it quite way through to the end, but this is a tree diagram. bag A can be on the first branch. Bag A. Yeah? What's that? 6 green, 4 red. So there's 6/10 chance of green and 4/10 chance of red. Yeah? Now, bag B, we're going to have to do some, this is representing bag B choice up here. We're going to have to do some thinking to do this, because if you notice, they say one marble is going to be taken at random from A and placed in B. Ooh. So suddenly you've got to think about what happened before. So if we took a green, there's now going to be 9 greens, 2 reds, and so the chance of another green is 9/11ths, yeah? Do you see what I mean? Because there were 8 green in bag B, but you put one of the greens in it, so you've got 9/11ths. Now if you picked a green, you're not increasing the number of red marbles in bag B, so that's still going to be 2/11ths. Whereas down here we picked a red and put it in bag B, and so that is now going to be 8/11ths and 3/11ths. If you get the bag drawn, the tree diagram drawn right, you're good. Because work out the probability that the green marble will be green, yeah, because it's going to be taken. Well, this is a second marble. A marble is then going to be taken at random from bag B. Work out the probability that this marble is green. Well, that's this and this branches. Those branches are where the second marble is green. So we need to do 6/10 times 9/11ths plus 4/10 times 8/11ths. And that's the probability of getting a green marble second. And that's 54 over 110 plus 32 over 110. That's 100 nickels. Okay, and so that gives you overall 86 over 110, which good for everybody. Pretty much everybody simplified it, but they didn't ask you to simplify, and if they don't, you don't have to, strictly speaking, but it's a good habit to be in, because most of the time they will ask you to simplify. Last one. Okay, this is hard. Yeah, I'll agree, this is hard. You've got, it's easy to get 2 marks on though. Do you know how to work out the volume of a cuboid? Yeah, that times that times that. So 4xy is 119. There's 1 mark. Yeah. Surface area is 155.5. This is harder. This is harder. People always fall down on the surface area of a cube. They really do. I've seen it so many times. Watch out for surface area. Okay, you've got this face and the back face. Well, they're both 4x's. 4x plus 4x. Then you've got, let's get rid of those now. So I've done the front and the back face. I'm now going to do the sides, that side and that side. Now that's 4y and 4y. We'll simplify that in a second. And then finally I've got to do the top and the bottom. Well, that's an xy and an xy. Yeah? Do you see where I'm coming from there? And so I get 2xy there. Let's add them straight together. Equals 155.5. Okay, so you've got 8x plus 8y plus 2xy equals 155.5. Okay, so there's your second mark if you get one of these 2 equations. So it's relatively easy to get 2 marks out of 5 here. Now, the third mark is much harder. But what do we need to do here? Ultimately, I think most of my students realised it's going to turn into a quadratic. It's just very few knew how to turn it into a quadratic. Well, we need a quadratic in one variable. So we need to get rid of another variable. Now, y is 119 over 4x. If I just plug that in there, excuse me, and in there, then I would have got rid of the y's. It looks really ugly at first, but it works a treat. If you did that, you would have had another mark, yeah? Now, multiply it all out. Multiply those brackets out. 8 times 119 divided by 4. Remember, you've got a calculator in this test, so you can do 119 divided by 4. And then times that by 8. And I've just done it with my calculator, and that gives you 238 over x. Same here, you can do 2 times 119 divided by 4. And it is, of course, 59.5. Now notice here, the x is going to cancel with that x. So this is 59.5, yeah? Equals 155.5. Now this may look horrible, but if you times through by x, you've got the quadratic I said would turn up. So 8x squared plus 238 plus 59.5x equals 155.5x. That's a quadratic. So 8x squared minus, if you take that away from that, I think you get minus 96x plus 238 equals 0. Right, our calculators as well. If you've got one of the good calculators, you don't have to have this, but it does make these kind of situations way easier because you can just get your calculator to literally solve the quadratic. I strongly advise you to to do that, really, because it just means, like, the paper's hard enough anyway. If you can just quickly do this. Oh no, I've typed it in wrong myself. I've typed it in wrong twice. Okay, you then can see straight away from calculator what it equals. You don't have to. I probably would factorize it just in a paranoid way, but you get x is 8.5. Now, if you want to find the corresponding y value, just plug it in here. 4 times 8.5 is 34y, which is 119, and so y is going to be 119 divided by 44, which is 3.5. By the way, you do get, I'll put y equals 3.5 down here, you do get, or x equals 3.5, in which case y equals 8.5. Naturally, as x is bigger than y, we want x equals 8.5, y equals 3.5. Cross out those ones because x is bigger than y. Okay, I hope that was helpful. Come and see us if you're still confused about any of these things. Like someone in the maths department will help you. Okay, keep up the good work and bye-bye.